I don't take a lot of pride in my videos. I'm just putting out information. Hope you can use it.
So this right here is actually the front of the press, and I stumbled upon this by accident, setting it up this way, because originally I was going to have the ram in the front, and I put together that part there backwards, and I was just fortunate because, hey, it's actually safer to put the ram on the back side. So this is the front, and what we have here, first of all, is this 20-ton air-operated hydraulic jack, and it was $113 at Harbor Freight. I used one of their great coupons, so I got it about $100. And then down here, this was these are my auto body dollies that I also got from Harbor Freight back when I fixed up my truck. I was doing a body work and a paint job on it, and so these are I'm assuming they're hardened, because they're auto body dollies, and they made I think they're going to make really good dies for drawing out. You can see they're gently curved like that, and I made it to where I want to be able to replace the dies. So this is just 2-inch square tubing that I had left over from the 2x72 grinder that I also made. Thank you, YouTube, for that video. Helped me through it. And of course, you got bolts here. You can take it down and move it, put on maybe fullers or flatter dies. And this right here, this is my removable die for the bottom. And this is kind of hard to do one-handed, so let me fumble through this. But you see, I just wet a piece of scrap 1/4-inch plate that I had laying around, some angle iron, and that slips over the, hang on, these iron plates that came with the press. And I didn't want to totally dedicate this press to blacksmithing, so if I need to actually replace bearings again, I can just flip this over, still use these, and still press a bearing. But I just took some scrap metal and I welded this to the C channel here to keep this from moving around. And you can see right here, I didn't want the two plates to slide, so this is just a pin, 3/8 inch mild steel round bar, drilled through it and dropped it in there. And these two, I got one here and I think one over here too. So they don't slide around. And let me come over to the other side and show you. This is just a piece of steel pipe, black iron. They call it black iron pipe, but it's actually made out of steel. It's not iron. But I just flattened it out with the press to make it more oval to fit the shape. So these are in there pretty solidly, and this doesn't move around that much. Of course, the whole support system here can move back and forth, that much. You just got to keep it lined up like that. So let me go back around to the front. Before I forget, let me make an important point. The first time I drilled through these plates, I drilled all the way through both of them, and I realized that made the pin just drop through onto the ground. So when I did the other one, I drilled all the way through the top one, but only about halfway through the bottom one. That way when I stick the pin in, it doesn't fall through. So anyway, just keep that in mind. Little helpful hint there. All right, so here is the back of the press, and what we have here is this is the relief valve, and this other fellow who made a similar press, he had to just he had to do this by hand as he was moving the the workpiece under here, and it was kind of awkward, and I didn't care for the way it was set up, so I just fabricated all these this lever here, and I needed some adjustability because you have to kind of tweak it to get it tuned correctly. But I was able to use my CAD program to figure out where to place everything, how long to make the bracket, how high up to make the bracket, and if you got a CAD program, you can kind of plan it out beforehand. But I still needed quite a bit of adjustability to make it work properly. But so this right here, this is just a little small pipe nipple. It's made out of steel, and I fabricated this this part here. And this actually is kind of stiff now, but this right here is it's quite a bit bigger than the pin because it does need some play. And the reason being is that the valve is not straight like this. It's kind of it's cocked up at about a 20-degree angle, you know, this way. So that plane, the plane of travel, is this way, right? So if I stayed in that plane of travel, I was worried that this arm was going to hit the body of the jack. So I had to basically offset this, and when you offset it, the ram actually will move sideways as it goes back and forth, and I'll demonstrate that. I hope I'm explaining this okay. I'm kind of rambling here, but anyway, so now one thing you have to be careful about is when you weld these two pieces together, there's actually rubber inside here. You don't want to get this too hot because you'll melt that rubber, then it'll leak. So what I did was I just tack welded it and immediately threw water on it to cool it off, and I did that repeatedly, so I was able to get a pretty good weld on it. Oh, and then once I had it tack welded, I took it out and replaced it with the relief valve from the old bottle jack, and then I took this over to my welding table and completed the weld. All right, so anyway, so this right here allows me to adjust the length of this arm here, and then I fabricated this little this part in here just out of a piece of 1/8 inch flat bar. And remember to make the hole bigger than the pin because it does need some play to move around. It was binding pretty badly, but once I wobbled it out or ovaled out that hole, it works real fine. Okay, so this is the air ram that I got on Amazon, and it's I think it's 32. It's called a 32 millimeter by, I forget the millimeter length, but basically the travel is 12 inches. So you convert 12 inches to millimeters and then search on Amazon for 32 millimeter by whatever that was, that 12 inches. But I'll try to remember to put a link in the description so you can just click on it and buy it. But it was cheap. I think it's about 30 bucks. And of course you can get the 1/4 inch line here from Amazon. And then I got a whole sack full of 1/4 inch press-on fittings here. And it was pretty cheap. And now one thing you do need to do is order some more screw-in nipples for the foot pedal. I'll show you that in a second. So this air here, this air line here makes the ram move out, and that opens the relief valve so that the jack can rise back up. And these springs are plenty adequate. As a matter of fact, they're too strong. It has a tendency to rise too quickly when I'm actually using it. This tube here is what retracts it, and it's naturally slow because you see I got a splitter here. This is coming from the supply. This pipe retracts the ram, but it also powers the pump. Now you're only losing air to this as once this ram is retracted, you're no longer losing air. So then the full PSI of the air supply goes to the pump. So it's only momentarily, it's dividing the air. Then when this retracts, now all the air goes into the pump. So that works out great. And just to give you a better shot of the mounting system, I just, like I said, on my CAD program, I figured out my dimensions, and you could just, actually you could probably just draw it out on cardboard, which is what I ultimately had to do. I made a cardboard template and taped it to this bottom of the platform to get all the spacing right. You can figure it out. I mean, if you're smart enough to take on this project, you can figure out everything. So anyway, now the other thing is I was able to get about 120 degrees of open and closing on this valve, and it opens and closes very quickly. So that's enough to fully open up that relief valve and get it going up quickly. So okay, let me go back over here. All right, here's the foot pedal, and it's a 5-way. I think it's called a 5-way 2-position foot valve. And it came with a kind of a toggle lock, so that when you pushed it in, it stayed, and you had to push on it again to get it to come up. I took that out, so now it's just, you know, spring-loaded and comes back. Inside here, these are your exhaust ports. So that's two of the 5 that they're referring to. I had to kind of do a lot of research to figure out the terminology of pneumatics. But here is the, I guess, the front of the pedal. You got A and B, and then S. S will be your supply coming from, or I'm sorry, P. A and B and P. So P is in papa. P is your air supply. A and B. A is, let me see, I wrote it down here. A is the ram out when the pedal is up, and B is the, airflow. A is airflow out when the pedal is up. B is airflow out when the pedal is down. So obviously when the pedal is up, you want the relief valve open. So that'll be ram extended. So I've got the A attached to the this end of the ram. That's the open, that opens the ram or extends the ram. And then B is this one. Remember I said B was the one that retracts the ram but also powers the pump. So when you press the pedal, you retract the, you close the valve, and it starts the air pump operating and lowers that ram. Now, this right here is a, God, what do you call it? Basically a restrictor valve. It's got a needle valve in it, and I put this in line with A to slow down the extension of the ram, because I've got this thing running on 120 psi, and the ram was violently extending. And so I got the restrictor valve to slow down the extension of the ram, and you can tweak it using this this little screw here. So now I've got it, working real fine. The supply line, I just did a connector to my airline here, so I can conveniently and easily disconnect it. Now these are what you also need, a bunch of these. These are quarter NPT, which is National Pipe Tapered, a quarter NTP. It was a little bit confusing at first. I had to figure it out again because of all these different nomenclature for threads. Quarter NTP, which actually this diameter here of the threads is almost 1/2 inch. So that's what confused me. And then your tube's a quarter. So you want quarter OD tube and quarter NPT threads. And that fits back in here just fine. And I'll put a link to, if I remember. I don't know. I'm not making any promises, but you can figure it out. So let me show the operation.